Hello guys, in this video we are going to simulate a propeller case using OpenFoam, similar to the one which you are seeing on the screen. So we will see all the step-by-step procedure to get this simulation along with the animation using OpenFoam and post-processing using ParaView. For meshing, we will be using snappyHexMesh, which is built in within the OpenFoam. So let's jump into the tutorial and let's see how to simulate this case. First, I'm going to open command prompt. Okay, now I have loaded my WSL in the command prompt. Now I'll go into the foam tutorials location or my foam run locations and then I will copy from there. Okay, now I'm going to create a new folder for this tutorial. I'll call it for Propeller tutorial. Now I'm going to go into that folder, and since we are using a existing tutorial case from OpenFoam, we are just going to copy that to this location. So you can type in this command or you can directly copy paste using the file explorer. It's your wish. This is an RAS model. Now we have the propeller case over here. And you see it inside, we have the 0 file, all clean, all run.pre and constant and system as usual. So we don't need all run, all clean those files. So I'm going to remove those using this command. Okay, now we just have these. I'll open my explorer on that location. Okay, so first I will rename this 0. The first thing what we have to do is we are going to create the try surface folder. To go into constant, here we have the dynamic mesh state, transport properties and turbulent properties as usual. Here we also have to make the try surface folder. After I create the try surface, we are going to load in an existing geometry from the resources of OpenFoam. We are going to use this command for that. Now we can see that we have around 7 files in this location. So everything is .obj.gs, which is a zipped file. So we have to unzip everything. So to do that, we are going to use this command. Now if you see, everything we have here is a .obj file. So that's it for this place. Now we can now we are in the system location. So the next thing which we have to do is set up all the case files. First we have to use surface feature extracted. I'll open that, and in this folder you can find the first line commented out. So here's this, and you can just leave everything else as default. We are just using the .obj files here. That is exactly why we unzipped everything. Now you can close this. Okay, the next location which we have to go is the block mesh dict. This is pretty much the default which you do not want to change, so this is fine too. And you can, if you want to see what is there in other things, you can see the control dict is just the default which you are going to use also, so we don't want to change anything. But we want to go into snappyHexMesh because there is something which we want to do. Inside the snappyHexMesh, you can find there are no addition of layers to the surface, so that is fine. But when you go down, you can find this propeller tip.obj.js here is in the zip file format, which we do not deserve, because when we go into constant try surface, this propeller tip is in obj format. So we are just changing it, and make sure everything else is also in obj just like here. But we do not want to change anything else over here. If you want to uncomment this out for the features, you can do it, but in this case we are not going to do it. We'll leave it as such, and everything else can be default because we are just running a default tutorial case. If you want to customize it, it's up to you. You can use the documentation and customize it according to your needs. Okay, so the first thing which we are going to do is run block mesh. Has successfully run. Now I will run the surface feature extract. This is successful too. So the next thing which we want to do is decompose. So I have multiple cores in my laptop. I have around 8 cores. So I am going to run parallel computing. I am opening this case, the decompose project. Here this is x-axis, y-axis, z-axis, and number of domains is the number of cores you have in your laptop. If you don't have the information of how many cores your laptop or PC has, you can do this simple thing. Open your task manager and go to this, and in the CPU you can find what is the number of cores you have. OpenFoam does not allow hyperthreading. It cannot read all the CPUs, that is the logical processors. It can only make use of the main cores, main CPUs. So you just want to make sure that you are using this number on not the number of threads. You want to use the cores. And close this. So I have 8. And this is the parameter where you want to decompose it. So it says x multiplied by y multiplied by z. So when you multiply these 3 numbers, you have to get this. So this is the number of subdomains the algorithm is going to make. In this case, it is going to split the y-axis into 4. Since it is a cylinder, it is pretty much essential or sufficient to decompose this y-axis into 4, but since I have 8 cores, I can speed up the process. So either I can put 2, 2, 2, or I can make something like this. It's up to you, depending on the geometry. In this case, I'm just choosing this. If you want to do like 2, 2, 2, it is fine also. Okay, now I will decompose the case. So to decompose, I'll use this command. Now you can ignore this because we have not set up the boundary conditions like U, P and all. So you can ignore this fatal error, but you just want to make sure that we are getting up to this line, the number of processor faces and these things. You want to make sure that there is 0, 1, 2, 3, 4, 5, 6, 7. So if it is up to there, then no problem. So since we decomposed it, we want to run meshing. We are going to use snappyHexMesh for meshing. I'm going to clear this. To run decomposed snappyHexMesh, that is, we want to run the meshing in parallel process. So I'm going to use this command. So what MPI run is that it takes the parallel processing. It has all the commands inside. So MPS, the default case which we want to run. The NP8, it says number of processor is 8, and then the syntax. What is the command which you want to give here? If it is not a decomposed case, what you will do is we will just type in snappyHexMesh. So that is a command which we are giving to the command prompt. So we want to give this, and then the parallel. This is a default syntax, but the override says when we are running something in parallel, it tends to do it in the order of time steps. So it will create something like 0.0001, and then the next iteration of meshing will be like 0.0002. So we don't want to do that. We want to overwrite everything in the 0th time step. We want to make the latest mesh inside the 0th time step itself. We don't want the next time step to have it. So I'm just going to run this. This is going to take a while.
A few moments later.
The meshing is over. We want to make sure it says end. Now when we run check mesh, that is where the checkmate is. We want to see if all the mesh is okay. In this case, the mesh is okay, so they're just fine. Now we want to reconstruct everything. We have decomposed everything, so we have split everything into 8 segments. Now we want to reconstruct all the mesh into one part so that we can actually have a single mesh file. So to do that, I'm going to use reconstruct par mesh, and we want to do that in a constant process. So I'm giving the command as reconstruct par mesh -constant. So once this is over, you want to make sure that it properly says end without any fatal error, and it also has your processors 0, 1, 2, 3, 4, 5, 6, 7 up to the number of processor which you have mentioned in the decompose bar. Okay, once we do this, we are going to visualize the mesh. To do that, I'm going to create a paraFoam file, this paraview file, which is an OpenFoam case. Once I'm in the case directory, I can open this. So to visualize the surface with edges, you can go here. This is the mesh file. Now here you can see that we have the propeller, and I'll slice it or flip it to show it to you. Okay, this is the generated mesh. So it's not the best mesh you can provide for such a case, but this is the default case which we have. They have given an OpenFoam. If you want to customize it, you can do it. Definitely, this is not a good mesh to run your case, but just for learning the process of doing this tutorial, it's fine. It is converging properly, so it should be fine for learning purpose. Now I'll close it here. And as you can see, we have all the 8 parallel processes which is there. We do not want those, so I'm going to delete those files. Now we just have the original files, or the system files. Okay, now we have one thing to do, which is Topo Setting. So what is Topo Setting? So when I go into constant polymesh, and when I open the boundary, you can see like 7 cases. That is 1, 2, 3, 4, 5, 6, and 7. We have 7 domains, but you can't find any. All these are walls, right? Walls, and everything is a wall, but you can't find inlet patch and outlet patch. So we want to make a topo set that will create the inlet and outlet patch and merge it with this boundary. We are inside the boundary file, and we can find only 7 now. So all 7 are walls. We are going to make the topo set. So to make the topo set, you can go into system, and in here you can find this file, create inlet outlet sets.toposet.dect. I'll open it with the text editor. Here you can leave almost everything by default. You don't want to change anything. In case you are importing a geometry on your own in a different case, then you have to give the named selection over there, and it is a totally different process. But to run this tutorial, we have to follow this. There are other ways to create inlet and outlet. So just for this tutorial, we have to follow this. I'm going my command prompt, and I'm going to initiate that topo set. So to do that, the command is topo set -date. So the location. So we are inside the propeller location. So we want to go into system, and inside the system, we have to type this exact name without any mistake. So I will it like this. So it is exactly create inlet outlet sets dot topo set tick. It is case sensitive. You want to make sure that you are not making any mistake. I hope I did not. Yes, I did not. Okay, we have created the topo set. So what that command will do is, when you go into polymesh, initially we did not have this file called sets. We only had these original 8 files. So when we go into sets, you can find the inlet faces and outlet faces. All these will be numbers. So these are the patch numbers. We do not want to know what are those actually. So when you check it, all we have is just the number of patches. So now we want to merge it inside the boundary. So as you can see, everything in here again is just the 7 walls. So we want to merge it. So to do that, again we want to go into the command prompt and give this command create patch and overwrite. So what this will do is it will overwrite the inlet and the outlet faces, but it is also going to initiate 2 patches called AMI1 and AMI2. We will see what are those. It is the type of cyclic AMI. We'll visualize it in the paraview. So now we will go into constant polymesh inside boundary. Now you can see we have AMI1, AMI2, inlet and outlet. So we have created the patches as needed. Initially it was wall 2, but we do not want wall, we want a cyclic AMI. So that is why we are changing the patch. Now we can close this. All the initial setup is done. So we can just run this case. To run this case, again we want to decompose it if you want to do it parallel processing, or else just type pimpleFoam. If you are just going to type pimpleFoam, it will run directly, but I want to do the parallel processing. So I'll do decompose par, and it is nice. So it is done. I'll refresh this. Yeah, we have 0 to 7. Inside each case we will have the 0 and constant. The system files will be common, and inside constant we will have the boundary and all the dependency files. So after we do this, we can run the case. So to run the case, you can type mpi run np, the number of processor which you have mentioned in the decompose par, and this is a pimpleFoam tutorial. So we want to use the pimpleFoam command along with parallel. Now when I run this, it is a very large case and it is going to take almost around 4.5 to 5 hours. Okay, so I ran this already and it took about 4.5 hours. So I'm not going to run it all over again. I have those case files and I'll just tell you how to do the post processing. I'll just stop it over here, but you wait till it says the solution is over or it reaches the timestamp. If you go to the control date, you can see the end time is 0.1. So you can see that over here, this is the time. it has to reach up to 0.1, but if you see here the way it is progressing, here it is 0.00145, here it is 0.00176, so that is how slow it is running. Here you can see it has not even reached 0.3, it is still in 0.002. So it is running pretty slow because the time step is very small. It is 10 to the power minus 5, so it's going to take a very long time. And I'm not changing any of these to make it faster because we want a converged solution, since it is transient and considering the mesh is very coarse and it's not very good, so we don't want to change any of these. Just for the tutorial case, if you want to make your own case, then of course you have to change it and see which time step suits you the best. Now in this case, I'm just going to stop it right here, and once it is over and says you have the solution, all the time step is over, it is converged at 0.1 time second. So all you have to do is type this command. So it's clear. You have to type reconstruct bar. So when you give reconstruct bar, actually it will construct everything, but since we do not have any time step now, it is not writing it. It is not writing the composed or constructed version of time steps. So if your solution is completely done, it will reconstruct everything. Okay, now we can go into post processing. Since I have already run the case, I will go into that. These are the time steps. So once everything is over, when I give reconstruct, all these processes are like processes 0, 1, 2, 3, 4, 5, 6, 7, all of these have each time step from each part of the mesh. So the reconstruct bar will put everything, all the data together and create these time steps as files, which we can view through the paraview. I'm going to open this paraview case. Once I'm in the paraview interface, I'll select apply. Here we have the mesh, the overall mesh. You can see everything is created. We can just visualize the propeller alone. Yeah, it is nice. It is very coarse, but yeah, it is okay to just learn it. Now we will just select the internal mesh. What I'm going to do is that select all these four, and I'm going to slice it. Okay, and this I'm going to create a contour. Okay, so we have this. So this is what we wanted. I'll go to the latest time step, or somewhere just before the final time step. Okay, we have this. Okay, in this contour, we are going to select. Sorry. This should not be solid color. It should be hue. Okay, so I'm going to change the color now. I generally like to keep this in dark blue color. We do not want this like as of now. Now I'm going to click this. Make sure you are clicking this and it's not selected anywhere over here. Go to open, click pimpleFoam, again the same case file, and open it again. Make sure internal mesh is selected. Now we want to create this slice over here, and actually we are not going to use anything over there. I will deselect the show plane. We don't want it. This slice, it's going to show the velocity in this section. So I like it to keep it in this color, because rainbow uniform is pretty contrast than turbo. You can see the turbo is not very contrast, but rainbow is a bit contrast. So I personally like to keep it in that, but it's up to you. If you want to change it, you can change it. Okay. By default it would be something like this, but I just invert the colors so that it's more bright. Okay, now if you want to check how this animation goes, you can do the animation by clicking on file, save animation. So you can type the file name, render, and you can set the format also. If you want to do it in MP4, MP4 will just give you the video, but if you want to keep it as PNG, then you have to make it as a video using some video editing software like Premiere Pro or DaVinci. So just select MP4 and you can choose the frame rate. Here the time step is something like this. It moves on by 0.01. So for this case, in my opinion, keeping the frame rate around 10 should be goodish. It will be good to view. So I rendered that also. So this is the final animation which we got. If you liked this tutorial, consider subscribing to my channel, drop down a like. If you have any doubts, you can drop down in the comment section.